So this is concept 2. In this video, we are going to discuss the possible hybridization of carbon in carbon compounds. So what are the different possibilities carbon can undergo hybridization, and what is the exact meaning of hybridization? What is the arrangement of hybrid orbitals? These are the things we are going to discuss in this video. Even before going to hybridization, I just wanted to discuss one point, that is excitation of a carbon, because in every organic compound, every carbon forms four bonds, that is from first excited state. So how excitation of a carbon takes place, let us understand that particular point first. So this is the ground state electronic configuration of carbon, that is 1s2, 2s2, 2p2. In the ground state, there are only two unpaired electrons, so it can form only two bonds. But a carbon always shows the tetravalency in all its compounds, and in order to form four bonds, it has to have four unpaired electrons. So during the formation of a bond, carbon undergoes excitation. So here, by absorbing energy, it will change from ground state to excited state. So this is the first excited state of carbon. You can see there are four unpaired electrons. So here this is 2s1, 2p3, totally four unpaired electrons. This is inertial core shell that will not participate in bond formation. Only valence electrons will participate in bond formation, and this is about excitation. In every compound of carbon, so carbon is present in a first excited state, and always it has four orbitals, but this is before hybridization. These are atomic orbitals. The atomic orbitals are 2s, 2px, 2py, 2pz. sp3 hybridization. First you have to know the meaning of hybridization. Hybridization means mixing of atomic orbitals and redistribution of those orbitals into new orbitals. sp3, that means one s orbital and three p orbitals. These four orbitals intermix, they share their energy equally, and they produce four new orbitals which are identical. They have a same energy, same size, same shape. Before hybridization, you can see the energies are different. 2s has less energy, 2p has more energy, even shapes are also different. But once hybridization is completed, you are going to get four orbitals now. sp3 hybrid carbon, sp3 hybrid carbon has four orbitals. They are sp3, sp3 and sp3. Four sp3 orbitals, degenerate orbitals, means they have same energy. So this is before hybridization. S orbital is spherical and p orbitals are dumbbell in shape, and after hybridization they share their energy equally, intermixing, sharing their energy equally, and redistribution into new orbitals 1 2 3 4. You are going to get four sp3 hybrid orbitals. All four orbitals are identical, and how they are present around carbon, they occupy the corners of tetrahedron. So this is the object tetrahedron, and this is the carbon. Around carbon, if you see, the four sp3 hybrid orbitals are occupying the corners of tetrahedron, and this is about sp3 hybridization. sp3 hybridization. Now this is sp2 hybridization. So mixing of one s orbital and two p orbitals, and this is always from first excited state. So this is the first excited state of carbon, but here we are saying sp2 hybridization. One s orbital and two p orbitals are intermixing, sharing their energy equally, and they produce new orbitals. Only three orbitals, 1 2 3. Now these three orbitals are sp2 hybrid orbitals, and there is one orbital which is not hybridized. Now this is atomic orbital. Now if you see the situation of sp2 carbon, carbon always has 4 orbitals. If you are talking about sp2 carbon, there are 3 sp2 hybrid orbitals. These are having same energies, and one unhybrid orbital, that is atomic orbital, p orbital. And if you see the arrangement of these 4 orbitals, 3 hybrid orbitals, 1 unhybrid orbital. Hybrid orbitals occupy the corners of triangle. If you want to see the arrangement, see these are yellow in color, these are hybrid orbitals, and this is unhybrid orbital, p orbital, which is not involved in hybridization. This is the top view. If you see from side view, so 1 2 3 they occupy the corners of a triangle, and this is the plane, and perpendicular to that plane there is unhybrid orbital, that is p orbital. sp2 carbon has 1 2 3 sp2 hybrid orbitals, one is unhybrid orbital, and these are in the same plane, and this is perpendicular. P orbital, that is dumbbell in shape, that is perpendicular, and this is about sp2 hybridization. So now it is sp hybridization. You see sp, mixing of one s orbital, one p orbital. This is the first excited state of carbon. 2s, 2p, 2p, 2p. According to this sp hybridization, s orbital and p orbital are intermixing, sharing their energy equally, and there are two unhybrid orbitals. Sp carbon situation is this one. It has totally 4 orbitals. 2 are hybrid orbitals, 2 are unhybrid orbitals. Unhybrid orbitals are p orbitals. They have more energy. Hybrid orbitals are only 2. So here this is one sp hybrid orbital, this is another sp hybrid orbital, and this is unhybrid orbital, this is unhybrid orbital. These are perpendicular. So this is about hybridization of carbon.